بعد كده حطوا
ممكن نحط AI في كل مكان.
كوزموس ديبو
AI for AI.
Hello everyone, welcome to Azure Qatar Community event. This is our 7th event of this year. Today we have Julien. He's a global black belt working in Microsoft, and today he's gonna show us the Azure CosmosDB, which we will use it in our projects a lot. So I will leave the stage to Julien, and thank you very much. Have a good session.
Thank you. Good evening, everyone. So my name is Julien Michel. I'm French, but based in Qatar since almost 3 years now. I'm technical sales lead for CosmosDB and open source databases in our territory, which is called CIMA. So it's vast territory, 65 countries, Central Europe, Middle East, and Africa. So for the next 90 minutes, something like that, we will discuss about CosmosDB. Who knows CosmosDB first? Maybe in the room.
Know or work at CosmosDB?
At least know the name. Working with? No one? Oh, okay. So let's start by some figures about CosmosDB. Just to give you a little bit overview about the criticity of the system and why a lot of customers and even Microsoft are using it heavily. So for your information, it's used in most of our services as a backend for different purposes. Teams, for example, is using it. Office 365 is using it. And even if you are using today ChatGPT, CosmosDB is behind the scene in ChatGPT. So we have thousands of customers, of course, in the world using Cosmos, for not necessarily for big workloads. Even if we will see that CosmosDB has really, specific capacities and features that, of course, make it very suitable for critical workloads. But you can start small with Cosmos, and you can grow your business and your usage very, very easily. We will discuss also a little bit about the use cases that we can see with Cosmos. But start with, if it's working, yeah. So just to give you an overview of Cosmos, it's a fully managed database. It's a NoSQL database, NoSQL distributed database. It's a database as a service in Azure. So you don't have to manage VMs and configuration and so on. You just need to care about your data that you can distribute everywhere in the world. So it's available in all the Azure region. That's why it's a premium service in Azure. We manage all the infrastructure part, all the backups, all the security and so on. It's a flexible database also in a sense where you have different operational mode of Cosmos. Either you use it serverless, provisioning mode where you provision specific resources, and we will see which kind of resources. It can adapt also, because I said it's a distributed system. So in a distributed system, generally, we have what we call eventual consistency, meaning that you can read and write the data on different servers. CosmosDB can work from eventual consistency to strong consistency. And also we have different models. Strong consistency is what you will find in monolithic databases. So you have one server and you read and write on the same server. Versatile, in a sense, CosmosDB offers different APIs. So you have the same backend, and on top of it, you will have different APIs. And one of these API is PostgreSQL. So we have a distributed version of PostgreSQL, which is part of CosmosDB. And so you can work either with non-relational data, with the NoSQL world, or you can work with relational data with scalable database like PostgreSQL. And we expose different kind of APIs, and we also expose different SDKs for our customers to work with CosmosDB. Scalable. So you have almost no limit in Cosmos. So you can really start small, and the system can automatically scale and we will see it's very easy and seamless for the customer, and you don't need to care about anything. We have, and it's one of the few services in Azure which is providing SLAs on performances and availability. Of course, it's integrated with Azure, well integrated. So most of the services will integrate with Cosmos. So it means that you don't have to develop anything on your side. You just have to add services and use the existing connectors. Most of them will be available from the CosmosDB interface, and others will expose connectors to connect to Cosmos. And the last part, of course, it also gives you the capability to run hybrid workloads. So operational, analytical, and also integration with AI. Meaning that you can integrate CosmosDB with either Synapse, either Fabric, or Databricks, or Azure OpenAI. So we'll go a little bit more in details in the different capabilities. As I was saying, basically Cosmos, it's a PaaS service. So it means that you just have to instantiate an account in Cosmos, so an instance of Cosmos, and then we are managing everything for you behind the scene. So even if it's a distributed system, you don't have to deal with the complexity of a distributed system. You just see one database, and you access to this data with your application or with different interfaces, and you ingest your data or query your data from the service. Available in all Azure region. It can work in one region, or you can automatically replicate your data in different region. It means that Cosmos can work in a master-slave mode, saying that you have one main region and you will have some kind of read replicas in different regions to push your data closer to your customers or to your application. Or you can decide also to have a multi-master environment. And again, it's something, the complexity is managed directly by the service. And so you can have read and writes in any region where you have deployed your Cosmos DB. So it's a NoSQL database, meaning that you don't have to care about the schema of your data. You ingest JSON documents, and you can have different models of JSON documents into the same container. And Cosmos DB will automatically manage the data structure and the indexation of your data. I was speaking about the three different modes. So this is what you can see on the right side, saying that we can use Cosmos DB as a serverless database. So you don't use it, you don't pay for it, and you will have access to a certain amount of resources. Or you can provision resources, and we will see what are the units that we are using for Cosmos. Either in manual mode, saying that you are provisioning a fixed amount of resources, and you will have always access to this amount. Or we have a mode which is called auto-scale. So the system will automatically add more resources when your workload is evolving. And the three different modes of consistency, so from eventual to strong consistency, we have the default mode, which is in the middle, which is session, meaning that we are guaranteeing strong consistency into your application session. Versatile, again, so you have different APIs or offers on Cosmos DB. So you can either use what we call the NoSQL, which is a core API of Cosmos, the default one, or you can, if you have existing Cassandra workloads, you can use either the Cassandra API or what we call the Cassandra managed instance. If you are planning to migrate MongoDB, we have also an API, or no, we have a new offer that I will also detail a little bit, which is called vCore. And if you want to do some relational workload, you can use PostgreSQL, so the scalable version of PostgreSQL. Again, we are providing a different type of SDK. So most of the languages, or at least the main languages, are supported. So of course, .NET, Java, Python, Go, main languages will be available. And if you are using Cassandra or MongoDB or PostgreSQL, of course, you can use the default drivers in your application. So either the MongoDB driver or Cassandra driver or ODBC to connect to your instances. So these SDKs are used to connect to the NoSQL version of Mongo. The goal is, of course, to be able to leverage existing skills of our customers. So if a customer is already working on MongoDB or Cassandra, we don't want them, to have a learning curve to migrate everything to CosmosDB and to learn how to query their data in Cosmos and so on. So that's why we are proposing different offers to make it easier for them to migrate to Cosmos. Again, distributed system. So it means that even if we are seeing one instance, one database, behind the scene, the data will be distributed over several servers, physical servers, depending on what you have provisioned on the load of your application. But again, it's something that you don't see. It's something that you don't manage. The only thing that you will have to manage in Cosmos, it's what you can see in the first line. We have logical and physical partition. Physical partition are the physical servers, virtual machines. Logical partition is to tell to Cosmos how you want to distribute your data into the system. It's a way to logically group together documents sharing the same logical partition or logical partition key. Data will be replicated into the system, so we have always several copies of the data to guarantee the fact that we are never losing any data in the system. Indexing and indexes are managed also directly by Cosmos. You have different type of index that you can create, and the system will automatically update indexes depending on the life of your data in CosmosDB. And of course, we will have a part in the presentation just to touch a little bit about and speak a little bit about partitioning, because it's one of the main thing to know in Cosmos, because it's a distributed system. If you want to have good performances and to use CosmosDB in an efficient way, in terms of cost also, you need to understand how the partitioning is working and what it means for you and for your application. And the last part, of course, is the scalability. The fact that the system can scale automatically depending on the load of your application again. If you configure auto scale, storage will automatically grow independently of the offers that you are using. You just ingest data into Cosmos, and the system will automatically add new servers when it's needed. So you don't have to manage, size of disk or so on. It's done by the system. So in terms of SLAs, as I was saying, it's one of the few services on Azure where you have both SLAs for high availability and for latency also. So by default, Cosmos guarantees 4 nines of availability when you are using Cosmos with a single instance in one region. If you start to replicate Cosmos in multiple regions or multiple AZ availability zones, you can go up to 5 nines of high availability in the system. That's why Cosmos is heavily used by banks for payments, mainly for instant payment, for transaction between banks or different entities, because of this availability, and also because of the latency. So we guarantee with the No SQL API that all the reads and writes of a 1 kilobyte document will be done in less than 10 milliseconds. We guarantee also, of course, the consistency and the throughput that you are provisioning. So if you are using a provision mode, and if you are provisioning a certain amount of what we call the request units, we guarantee that you will always have access to this amount. Same thing for the consistency. If you configure eventual session strong consistency, we guarantee that it will always be executed with this consistency level. We can see here different services which are integrated with Cosmos. So Azure Data Factory, Azure Event Hubs, what can we see? Purview, Fabric, Azure OpenAI, AKS, Synapse. Yeah, all these different services are fully integrated with Cosmos. And the last part was about the fact that because we can integrate with Synapse and Fabric, both. And the fact that what you can see at the top, it's integration with Synapse. In CosmosDB, we have two different types of storages. We have the transactional store, which is used to store your JSON document. If you enable the connection with Synapse, you will have to enable what we call the analytical store, which is another storage side by side with the transactional one. But where we are transforming the data, the JSON documents, into a columnar format to be more performant with analytical workload. And the Synapse will automatically connect to this storage, which is synchronized in near real time with the transactional store. And you will be able to use SQL Engine, Spark Engine to execute queries, analytical queries on top of the data, which is coming from CosmosDB. And for Fabric, in fact, we have a mirroring of the data into Fabric to be able to do the same, basically execute heavy analytics queries on top of data without impacting your customers and your transactional workloads. So it means that you don't need to transfer any data. The system is managing it itself for you. So you don't need to have any ETL tool to do this transformation and transfer. And it's a seamless integration. So I'm not speaking about the vector search for the moment because I've got all a section about it. Any questions so far? No? So I will just focus a little bit on the scalability and the way it's working. So as I told you, we have in Cosmos what we call the physical partition. So you can see as small servers with some limits that we are provisioning to store your data. When the volume of your data is growing, you will see that, of course, the size of the data in each server will grow. And we will reach, at the moment, a limit because each small server has a limit in terms of volume of data of 50 gigabytes. So you know that each 50 gigabytes, you will have a new server that will be created into the system. And it's data plus indexes. Now, the system will automatically create new servers and redistribute your data on the new servers because we reach the limit. And so the system needed to go behind the scene. Second thing is about the performances. And so the number of concurrent queries that you will have to execute on CosmosDB. This is the second aspect that we need to scale in Cosmos. So more you will have queries, concurrent queries, more you will need to provision, so what we call the request units. Request units is the unit that we are using to size Cosmos. It's basically an abstraction of the physical resources which are needed to execute your queries. So it's an abstraction of the percentage of CPU, memory, IOPS that will be used by the query when you are executing it on your system. So when you increase your traffic, so let's say you started with a certain amount of request units, so 48, then you increase, or the system automatically increase if you use autoscale, to 60,000 request units. Why 60,000? Because, in fact, we have 6 physical servers. And just the next one. Okay. So we move from 8,000 request units per physical server to 10,000 request units per physical server. And this 10,000 request units is the limit per physical partition. So for each physical partition, we have 2 limits. One is the size of the data, so 50 gigabytes. And one is the number of request units that can support this server, because it's a machine with memory, CPU, and so on. So of course, you cannot use as much as you want one server. And so when the traffic will increase, you will have, again, to increase the number of request units, or the system will do it by itself again. And what the system will do behind the scene, it will create new servers again, redistribute your data, And what you can see and what is important, that's why it's also important to understand, the distribution of the data in the system. You can see that you now have access to less request units per physical partition. So what does it mean? It means that if you execute queries only on one physical server, meaning that if you are using, for example, a query with a filter that will use the partition key. So as I said, the partition key is there to logically group documents together on one physical server, because the size of a logical partition is lower than the size of the physical server. So in a logical partition, you can have no more than 20 gigabytes of data when you can have 50 gigabytes on a physical server. So it means that one physical server can store several logical partitions. But if your system or if your application is using a partition key to query the data, and if you are always querying or using the same partition key, it means that the system will always go on one server. And even if you have provisioned 81,000 request units in the system, and that you can think that it's a lot, and it can cost a lot, effectively, the system or your application will have access only to 9,000 because it's always going to the same physical server. That's why it's important to understand that it's a distributed system, and you need to think about the strategy to distribute your data into the system. Otherwise, you will be facing some limits, and even increasing the global request units of your system will not help you to overcome the limit that you are reaching with one server. Is it clear for everyone?
Just a quick question. So how do you decide how many request units do you need? Like, do you look at, is it like one request unit translates to one read, one
Yeah, we have some back. I've got a slide to show you about it, but yes, it will depend on the type of workload that you are executing on the system. Are you doing only reads? Are you doing read and write? Are you doing a lot of updates, deletes, and so on? So we have a tool that we can use, which is called the capacity calculator, capacity planner, where you can define your workload, number of read per second, number of write per second, number of delete, update, and so on. And the system will automatically calculate, based on the size of the data that you are ingesting, an estimation of the number of request units that you need for the system.
How do you decide the logic partitions? Like, are you thinking like based on business logic, so like things that get called together, or?
Yeah, it depends of the use case, in fact, because you will see that in terms of use cases with Cosmos, we will have a lot of different industries going from banking to retail to IoT. So depending on the type of workload that you will have, depending on the type of, will you do only point reads, saying that you will ingest data and you will get only one document at a time? Will you need to do cross-partition queries because you need to get documents from different partitions with different values? Will you get several documents together? So depending on this question and the type of queries that you are doing, we can decide which type of partitioning we can put in place to be efficient.
We have introduced the new servers and how the data distribution will happen. Like earlier, there were only 5 servers.
Yeah.
We now introduce around 2 or 3 more.
Yeah. So in fact, each server owns a range of value for the partition key. So each time there is a new server which is going into the system, and it's not coming, 4 by 4 or 3 by 3. It's evolving depending on the evolution of the load. But each time there is a new server coming into the system, there will be a redistribution of the ranges. And so all the server will own different values for the partition key.
What is that mechanism? How the system decides?
It's an algorithm inside the system that you cannot tune it. It's done automatically. So it's made to be as much as possible to have an evenly distribution of the partition key into the system. This is the different models of CosmosDB. So I was telling you, serverless, it's an offer that we launched, I think, 1.5 years ago. It's mainly for small workloads, for development, for testing, because you have some limitation in serverless. You cannot do multi-region with serverless. You have a limitation in terms of performances and in terms of size of the data that you can ingest into. But you have a very good cost of usage with serverless. Because again, serverless advantage, if you are not using your instance, you don't pay for it. So you don't pay for the request unit. Of course, you pay for the storage because the storage is persistent, but you don't pay for the request unit that you are not using. And then we have the two provision mode. The first one was, and the first which was coming, it's the manual one. So manual means that you provision a certain amount, and I can see that it's not really accurate. So you provision an amount of request units, and you will always pay for this amount of request unit, even if you are not using it. And we have autoscale. So autoscale, you provision a maximum, and the system will automatically scale between 10% of this maximum and the maximum. And you will pay for what you are using during 1 hour. So the maximum that you are using during 1 hour is what you will pay at the end. So if you don't know what will be your workload, it's good to go with autoscale. Of course, the differences between the two. Manual, the unit price of manual is lower than the unit price of autoscale. But because in autoscale, of course, if you have some this kind of workload, most of the time you will consume less than the maximum that you have configured. And so it will be most cost effective. But if you have peaks and a lot of peaks all the time, and if you are finally consuming all the time the maximum, it will be more expensive than manual. So again, this is the 5 different consistency levels that we have in Cosmos. Eventual consistency, what you have in by default in distributed system. Strong consistency, what you have in monolithic system. And you have 3 different consistency level in BI. And the one that we are using by default is session. Depending on the consistency levels that you will use, of course, you will have either a lower latency or a higher cost. Because the fact to use strong consistency means that you need to wait for the data to be replicated in all the servers that you have in your system. And so in Cosmos, in fact, you pay by physical resources. So each time you need to access to a physical resource, you will have a cost. So strong consistency will be, of course, more expensive. And the latency will be higher because you need to wait for all. Eventual will be very fast. And it can be used in, let's say, 90% of the use case, you can use eventual consistency. Because you will not read the data, as soon as you are inserting the data. And generally, the replication takes some milliseconds or second, but not so much. So eventual consistency is good enough. With a session, you have a good balance, and this is why it's a default one, where you will, in your session, in your application session, you will always read the last version of the data that you just write. And this is something that you can also tune. You can have a default configuration for your database, and you can, by query, you can change the consistency level. Something which is interesting also in CosmosDB, it's what we call the change feed. Change feed, it's a kind of queue where we are storing all the events happening on Cosmos. So each time there is an insert, an update, and a delete, we will store the information in a persistent queue. And this queue can be consumed because we can create trigger on it by Azure Function, by Logic Apps or other. It can be also consumed by streaming, so Databricks or streaming analytics. And it can be used also to replicate your data into another CosmosDB account, into another database or another storage or another collection. So we can use it for implementing materialized view, for example. You can have one collection where you store your raw data, and you can have other collection that will be automatically synchronized because in fact they will consume the change feed and there is an event which is triggered each time there is a new event in the change feed. And you will be able to update other collection with another partitioning each time you are updating the main collection.
This is like an audit trail, audit log.
I'm sorry?
This queue is like an audit trail, audit log with all the events.
Yeah, you have insert, update, deletes, which are done in your collection, in your main collection.
It will manage the previous and new value. For
Yeah.
example, if you do an edit.
Yeah.
Only DML level operations, not DDL, right?
Hmm?
But only DML level operations. Database mean insert, update, node, truncate, and
No,
table drop. Those.
just insert, update, and delete since recently. And we had two modes. One mode which is we keep only the last version, or one mode where we keep all the version of the modification. We have also an integrated cache in Cosmos that you can add on top of it. Even if we have millisecond latency, we still have some use cases where you need to have less than 10 millisecond guarantee. And so most of the time, customer will go to Redis, for example, Azure Redis cache, to add a cache on top of the database. So we have implemented in Cosmos the same concept, but the difference, it will be automatically integrated into CosmosDB, meaning that we are managing the synchronization between the cache and the database. Of course, it will improve the latency, but it's not used so much, in fact, because we are already providing very good performances. And most of the time, even if we have a SLA of 10 milliseconds, most of the time, even without the dedicated cache, we will have a latency which will be around 5 milliseconds, 4 to 5 milliseconds. So this is what I was telling you about the fact to have transactional store where we are storing, the JSON documents, and the analytical store, which is a column store, where Synapse will connect to access to the data in near real time without, again, impacting the application because it's two different storages. So all the access and the work which is done on the data in the analytical store is not impacting the transactional store. And this one is a mirroring of the data into Fabric, which will allow you to do almost the same thing, but the integration with Fabric gives you also the integration with OneLake, where you can merge data coming from different systems, and CosmosDB is one of these systems. So now maybe you ask yourself, okay, CosmosDB is a NoSQL database. Why do I need it, or when will I need it? So is my application needs CosmosDB? So you can ask yourself some questions about, do you need scalability for your system? Do you need to have low latency, guarantee on low latency? Do you need to have high availability and the capability to geo-replicate your data everywhere? Or do you need to you don't want to care about the schema on your data? So do you want to have a schema-less database? Or will you implement a microservice architecture? Or the last one, are you thinking about maybe creating what we call an intelligent application, where you want to add AI on top of your data to add intelligence to your data? So if one of these questions is true, it's a yes. CosmosDB can be a good fit. Second kind of decision tree, let's say. What do you need, in fact? And what is CosmosDB? What is the best fit for CosmosDB? So again, low latency, high availability, elasticity, meaning that you can increase or decrease the capacity, throughput, flexible schema. Of course, CosmosDB will be a good fit. If you have more analytical workloads, relational workloads, you don't go for a NoSQL database or a distributed system because it's not built for this kind of workload.
Can I add a few things as well?
You can.
Sorry for being late, team. I was having another meetings, but from relational, like most of us are from relational database, right? We understand tables, columns, and everything. Okay, but that's why it doesn't fit all the purpose. Cosmos DB or NoSQL database, I think Julien would have probably covered, but there is three main things that you need to be aware of. Sometimes consider that you have columns which are more than 1,000. Okay, relational structure. Whenever we start from education, we were always told to normalize table, not have like 10 or 15 columns in max. We normalize. In this case, consider you have 1,000 columns. You need a NoSQL database like Cassandra. Okay, consider that you have a document. Consider that if you are creating like reviews on your, let's say, on some articles, or you are creating, let's say, you are a grocery store and you have like you are selling, let's say, Carrefour. You are selling like fresh food items. You are selling TV and things like that. How would you create the model? In the relationship world, you will create a type that this is my product type, then you will create that this electronic types, then this is this, and you will create different type of thing. In Cosmos, the beauty is that you don't define the schema upfront. Okay, you define like you first in just a document, and then tomorrow, let's say you are selling something, and now you have, let's say, more people who have, let's say, specific allergies, and you are, let's say, a fast food chain. Okay, we will have pizza, let's say, later on. So you want to add like the allergies, whether there is any allergies or not. If you are in a relationship world, you have to do a lot of schema changes and everything. In Cosmos, you do that, and then you do the schema at read. That's the beauty that makes it very appealing for the NoSQL databases to be used. And unfortunately, we know relational world so well that you want to always use the relational world. And that's why I thought this session will be very interesting, that you guys should be aware of the Cosmos offering, which will help a lot in the application domain.
I have one question. Can you run Cosmos DB purely in memory or?
No.
No? Okay.
So in memory will be with a dedicated gateway, but otherwise no.
Yeah. But in NoSQL family, there is one which is Redis cache.
Yes.
You can run it, but the main thing is latency. Whether you require the latency on 1 to 2 milliseconds, or we can guarantee you with the persistence that you can do with 10 milliseconds, which
the reason I ask is because we have some use cases where we have some client data that we can only have in memory. We can't actually store on a hard drive, right? So we want kind of a fully featured database, but we also want it to run in memory. We've looked at Redis and things like this. That's why I asked.
So Julien for taking some time, but I just want to make sure that the team gets why Cosmos is so important.
No, we have a lot of time. So no, I will speak a little bit more about the integration with OpenAI mainly and different use cases. So as I was saying at the beginning, we have tons of use cases where Cosmos DB can fit different kind of industries. You will have transverse use cases. But yeah, you are speaking about, the schema-less capability and the fact that you can have a schema which is evolving. So if you think about a product catalog where you have a retail website, you can see that all the products will not have the same structure. And so having a JSON document where you don't need to care about what are the properties, because if the property is there, you will get it when you query your data. If it's not there, system that don't care, it will not give you an error for it. It will be indexed when it's there and not indexed when it's not there. If your schema or if the model of your products is evolving over the time, you don't need to update the schema in your database. You just need to ingest, documents as it is, and the system will automatically manage indexation of the data, the indexing of the data. Financial services, of course, as I was saying, instant payments because of the low latency of Cosmos and the availability of the platform. It's one of the main use cases in banking. We'll see a lot of IoT. So all the information coming from devices, very fast from devices that you store in Cosmos, and then you can manipulate the data to expose it to dashboard or so on. And a lot of different use cases around risk analysis, scoring, 360 views and so on. And we have some augmented use cases now with OpenAI, which is adding, of course, more intelligence to existing one. And one of the main ones that we will have today is, of course, the RAG application. So the capability to have a conversation with the application using natural language instead of, sending queries to your application and to your database. And so this is possible, of course, because of vector search. So the capability to search for similarities instead of searching for the exact terms that you are looking for. So in Cosmos, in the different flavors of Cosmos, we have the integration of vector indexes. And so we can use these vector indexes to be able to search. So what is the concept? Basically, you will have your data that will be your documents, images, text, videos, or anything that will be sent to OpenAI. OpenAI will generate what we call the embeddings. So it's a traduction of your documents or your information into numbers. And this is what we will store in Cosmos. And based on the values of these numbers, of course, the documents will be more or less close into the representation. And the vector search basically will do a search of the information that you are giving to the system, translate this information in numbers, and try to find the elements which are similar to what you are looking for. And so closer in terms of distance of the numbers that you are giving to the system to the numbers which are integrated or stored into the system. And so with the integration of vector search in Cosmos, it means that you can store both your data and your vectors into the same system.
This you can remember, by the way, from the first session that I did. I showed 3 databases. One was Cosmos, Postgres, and the AI search. I've shown how you can do that, the script. If you don't remember, you have to go back to the session on YouTube and
review the session.
Yeah.
And so this is what we call intelligent application. So it's not just an application which is the same for everyone. It's an application which is personalized for each interaction and based on what you have already did with this application. So I've got, for example, a customer in South Africa who is actually developing a mobile application. Do you know Thermomix? Maybe. Thermomix, it's a kitchen product where you can just enter a recipe and it will give you all the different steps to do your dish. No, you don't know it?
Can you spell it?
THERMOMIX, Thermomix. So it's very nice. It's connected to internet. You say, okay, I want to cook, I don't know, lasagna, and it will give you different recipes. And in the appliance, basically, it will tell you the different steps. So add, I don't know, the meat. It will start to cook the meat, then add the tomatoes and so on. And you follow the steps, basically. It's very nice. And one of my customers is actually working on an application which will give you the same idea, but you will enter in the application. It's a conversation, so it's a chatbot. You will enter, okay, I want to cook lasagna. Application will tell you, okay, to cook lasagna, you have different possibilities. You have this and this and this recipe which are available. Which one you want to select? You say, okay, I've got some allergies. I don't know, I don't want to have meat inside or anything. And it will, adapt the recipe based on on the inputs that you are giving to the application. And then when you are selected the receipt, it will tell you, okay, for this receipt, you need these ingredients. And because this customer is a retailer, groceries, so he has shops, application will automatically fill a cart in the application with all the needed ingredients and send the order to the nearest grocery shop of the brand. And you will have a delivery at home of all the ingredients that you needed to do your recipe. And you can ask what will be maybe what kind of drink I can have with this dish. I don't know. Is it better to have sparkling water or juice or anything? And it will give you some ideas of what you can drink with the dish. So it's very nice application. And all of this is based on existing catalog of the customer that it will ingest into the database with the capability to search similarities. So based on the conversations that the customer will have with the application and based on the preferences and the previous history of the customer with the application, it will be able to adapt the answers based on this information. So this is what is an intelligent application. It's not providing the same experience to everyone. It's taking into consideration the specificities of everyone. And to do that, you need, of course, different kinds of services. And also, it's a real-time interaction. So you don't want to wait, for minutes before getting an answer. You don't want to wait for minutes to have your order filled into the grocery. So you need to have real-time interaction. And it can be also based on prediction. So intelligence can come, from machine learning and AI to predict maybe because every Sunday or every Saturday you are cooking some specific dishes. So when you connect to the application, maybe it can predict that you will ask for some specific things and it can recommend you receipt based on this. And of course, you need scalability because the goal is to reach as much as possible customers. So in this type of use cases where we will find CosmosDB in this kind of generative AI use cases, semantic cache. So you were speaking about in-memory. The thing today is each time you are accessing to Azure OpenAI, of course, you are paying for tokens to get your answers. So CosmosDB can be used as semantic cache to provide a better latency than just waiting to get the answer from OpenAI, and also to avoid the fact to go for the same kind of queries to OpenAI and get the information directly from the database. Chat history, of course, this is obvious one. So ChatGPT, for example, you are storing all the chat history of your customers and you have the context also or the messages that you can send to OpenAI to give him more information and to get more accurate answers. RAG, of course, fact to be able to use natural language to have a conversation with your application. And the fact to be able to store so the vectors and operation data into the same database. So this is why CosmosDB is a good fit because it brings everything into one system. So data and vectors together, the fact that you can do so vector search on this data with different kind of filters. OpenAI and CosmosDB are exchanging JSON information, so it's a native format for both of the solution. Dynamic content, so of course you can use the change feed to update different information each time there is new data coming into the system. And the capability of Cosmos that we have seen with high availability, low latency, and so on. I wanted to give you some architecture example of CosmosDB. So this one is using the change feed. So this one is typically, a microservice type of architecture where you will have your application. And of course, in your application, as I was saying, CosmosDB, it's very performant when you provide, the right filter to access to the data. And so one of the use cases we've seen with the change feed is the capability to synchronize different collections together, which will be partitioned differently to give an efficient access to the data, so efficient in terms of performance and cost, because you will use different filters to access to the data, depending on the microservice which is accessing to Cosmos. And we have also the integration with the analytic part, with the analytical storage. This one is the one that we are speaking a lot, of course, in Microsoft. Probably you already spoke about it to your
Just on the
customers.
previous slide, just giving one example that I was working on Australia. So we were working on one of the customer in which they were tracking the real-time inventory. Okay, like consider the inventory when there is something happens, you want to trigger something. The ideal way in the most of the relationship world, how we will do it, we will start polling the tables and all the time see what is the query. That exhausts a lot of things. So consider that the record is updated and you automatically get a trigger that something has done, and they just take a trigger on that rows rather than polling the thing. So that is how efficient it can be. The other thing is consider that I was working in one of the customers where, like, I'll just tell you initially like my thinking. They were having a lot of smart meters from electricity, and they were ingesting a lot of data. Okay. I was the architect. The initial thing was, okay, put into something like Spark or put in something like a time series databases. But when we think about the scenario, there was two things. One is the read and one is the write. Okay. The Spark thing, I will just optimize mostly when I'm doing some aggregation or summation or analytics. But on the real time, if I'm extracting like record by record, it was not scaling up. So what we need to do is we have to put Cosmos in between to have the scalability to provide the ingestion at the speed, and then provide like this link, whatever like within the string that is providing that like to Synapse or Databricks to have the analytical workload. But in the meanwhile, the main thing, consider that you are your individual home and you want to see the meter information now. So you want to query your individual record rather than a group of records. And that is how efficient it will be that if you don't have that layer in between.
So a use case that everyone wants to implement today, it's of course the fact to have your own copilot. So a copilot on your own data. And this is what we are pushing a lot actually with our customers, because CosmosDB is of course very good fit because of all the information that we have seen before for this kind of use case. We just go until the end. So what is the flow basically? It's you have your own information. So information coming from your system. So you don't want your users to be able to access to ChatGPT and to potentially give to ChatGPT some internal information that can be reused because it's public. And so you want to be sure that your customers, your users will have access to the same kind of experience, but limited to the information that you have internally. And it will not go outside. So your document will be, of course, loaded into CosmosDB. So you will have your data and you will generate embeddings for all the data that you have in Cosmos. But you will not just store the vectors and, of course, the index on these vectors. You will also store the prompts and the completion. So completion will be the result of coming from OpenAI. And so you are asking to OpenAI to generate your embeddings. Information will be stored into Cosmos. And your user will just access to your application that can be deployed in a case. Send the question to your application. Question will be, of course, asked to Cosmos, thanks to also vector search, because it will request, so it will transform the question into embeddings. Do a vector search in Cosmos. Do also a query on OpenAI and send back the information to the customer and start the conversation with the customer. And all the information, so the question, history of the conversation, completion will be stored into Cosmos. So this is a kind, you have access on GitHub to this accelerator that you can use and deploy on your own. And we have a lot of customers who already started to deploy their own copilot based on this accelerator to be able to to provide this kind of experience to their customer.
Yeah, you would have seen that I showed this architecture previously as well, right? Like there was 4 different databases that are shown here. Okay, CosmosDB is one of them. Like if we are just using like kind of like the vectors part, is great because I don't have to look for other tools. I can save the chat history as well as like the vector considered as a vector database, and that provide like the architecture in there. So yeah, I think you got it already in the previous sessions as well. For chat history, we are always using Cosmos. For the vectors, this is one of the options and great option that we can use.
We have several examples which are available on GitHub that you can use. This one is another one which is a simple application with no interface, but it's just you load into Cosmos some recipes again. And what you can do, it's just with your application. So you can ask questions and say, okay, I want to cook a paella or something. And what will show you this application is basically that it's not just doing a search on the information which are available also in the documents, but it will take this information and it will interpret this information. And that's why you can see, so normally, in the JSON documents for other receipts, you will have all the instruction to do your receipt. In this one, you see you have information which are not related at all with the paella or with a receipt of paella. And you can see that, in fact, what OpenAI did, it has interpreted the information in the JSON documents to say, okay, it should be a joke because it's not. It doesn't look like a receipt. So it's just to show you the intelligence of integrating OpenAI with your application.
Just a few days back, I was discussing with one of the customers. They have the data already in Cosmos DB, and they were trying to find out, like they were trying to tally two documents. They would receive the JSON document from the suppliers, and then they would have ingested like some transformation in there. But they want to measure the key like attributes, whether they are the same or not, or they have transformed during the day. So they were saying that how can I do it? Like I already have a Cosmos DB. So what we did was we just said that you have to just provide the documents. We just send the 2 documents to AI, and we created the prompt, identify the key attributes which are different. And they get the result, and then they can do a trigger accordingly to do it. So it was very easy without even vectors, because we already know the search. We were just doing directly on the database. So it made it very, very easy to do the use cases.
Yeah, what I want to show you also, it's a short demo. You can see here, I put the link on also on the slide, where you will see all the different samples that you can have access to in GitHub. And so this will be.
You'll share the link on the group.
Which one?
This link to samples.
We can.
Yeah, we can.
Yeah. This one now you want the demo, or you want later?
No, later.
Yeah, later we will.
So this is a link. And here you can see, in fact, it's really dedicated to samples with AI samples with Cosmos DB. And you will see in this GitHub, you will have access to information, of course, what is a vector search, what is a vector database, so and how is it implemented into Cosmos DB, and also a lot of different code samples that you can use using different, again, because in Cosmos you have different flavors, so you have the NoSQL, you have MongoDB, you have Cassandra, also, or Postgres, and you will see different samples that you can use to implement your own, or at least to do your own test on integrating Cosmos DB with OpenAI, and to try to provide some intelligence to the application. So I use one of them. So you have here some Python notebook that you can easily, you can use VS Code to launch it. And this one is a simple one, which is
Julien, can you just zoom in, because it's, just zoom in.
Okay.
Control plus, right? Yes. Where is plus? Here. Just you need to, so the people on YouTube can see it.
So this one is very easy to use. You just have, you have your notebook. You just have to execute the different cells. You modify the information, so the configuration to put your CosmosDB configuration, OpenAI configuration, and it will be loaded automatically into thanks to the notebook. This one will load, in fact, information about movies, so a subset of a data set with different movies. And you have two notebooks. The first one is to set up the environment. So basically, it will just load the variable, create the database if you don't have one, create the indexes. So here you can see we are creating specific indexes for the vector search. We are using a specific type of, and by the way, this kind, in fact, is a Microsoft implementation of vector search, which is optimized for performances. Create a container. Then it will also connect to OpenAI to generate embeddings, and it will load the data coming from a zip into your CosmosDB. So here's an example of the data, so the JSON documents that you will have. For each movie, you will have the same kind of JSON documents. And then it will just store the data into Cosmos, and it will ingest something like 4,500 documents, I think, in 400, 500 documents into CosmosDB. When you are finished with this one, you can go to the second one, which is in fact the load of the demo. So same thing, you will just execute some cells, so it will install the needed resources, import the information, connect to your CosmosDB, connect to your collections, generate embeddings, vector search. So you have different methods to execute the vector search on Cosmos. So you can reuse it after that. So you have all the samples, of course, with the syntax that you can reuse. And in this application, we will store history, chat history. We will store also the completion here, and we will also store use one of the collection as a cache. So meaning if you are executing, the same kind of query, it will go directly to the collection instead of going to OpenAI. You have the pipeline function, LM1, and it will create also interface with Gradio. So we have nothing to do. You just have to execute, and it will launch this kind of interface where you can just ask questions, and it's a chatbot. I like with this. It will search in the database. So I don't know if it's still one. Yeah, it's still one. So it will give you in the database. Okay, so a simple search. Now, if we want to have something which is more intelligent, can you?
A lot of people will not even be born, I think, in the die-hard time.
Movies like Matrix, for example. So it means it's not a regular search because it's not looking for keywords into the description of the document. It's looking for similarities between movies because of some information and because of the vectors and embeddings that we have created to see which movies could be similar to Matrix. And you have different sample of more or less intelligent queries that you can use. Let me show you. So here is the logs also, which are generated into the notebook that you can see. Let's say, which one again? What movies did Tom Hanks star? Can I select? And you can see, so movies where we have Tom Hanks, which are similar potentially to Forrest Gump. So everything is based on what you will find here. So here you have the CosmosDB instance, where you will find two collections, one with the movie data. And you will see that on each document, you will have so information about the movie itself, about the type of movie, actors, dates, or so on. Maybe a description sometime. And you will have the vectors. So which means the mathematical interpretation of the information that are available into your documents. And we have a second collection where we will have information stored. So can you recommend movies similar to Matrix? Which one we'll find? So maybe some I have already used. But movies, the Tom Hanks, yeah, similar to Forrest Gump. So what I just entered, it's using this as a semantic cache. And if I do the same query, it will tell you, okay, I'm going directly to the cache because I have seen that this query has been already executed. So I don't need to go back again to OpenAI to get the information. So you have different samples available on, at this URL on GitHub that you can use, and you can play with it. Let me check what we can do. I think we need maybe 20 more minutes because I want to.
And I'll ask a question. Just on NoSQL databases. Which website or global website do you think would be using something like NoSQL?
Everything nowadays.
Everything, right? LinkedIn, Facebook, they are all like network inside, they are all NoSQL. The relationship will fail there. Although like relational databases are catching up, but it will not build for that purpose. So yeah, just keep that in mind. And secondly, like what Julien was showing about that is all in one place, right? So that's why like initially it just seems hard for relational people, but people who are like actual app developers, it's like it's amazing once you start learning it and you know the benefit, then you will know exactly why there is a difference and why you will need this one versus the other. So
I just trying to digest it.
Yeah.
For applications in real time, I get it, but if you're building like an analytical platform, how do you build it on the top and the schema is on the read? This is I'm trying to get.
There's two parts to your question.
Mm.
First, as I explained, that the analytical part is always with you first create the application like the OLTP application. The application needs to have the database.
Yes.
Okay, so you don't need to think about the analytics first. You need to first think about your application. Once the application is there, if there's IoT, you already covered that. IoT part you already covered. The application part consider a website, like what we are saying, like the product catalogs, recommendation engines. Recommendation engines will not have anything like an relational. They will always store it in a kind of NoSQL database because you need to create a profile of each individual user, like
This I understand.
yeah. Application, for example, if you are building any catalog, I give an example, right? If you open, let's say Carrefour, they will be using NoSQL database because for the product categories or the product items, it's not just like a product name or description. There is a lot of details about what is the size of, let's say, a TV. What is the brand of this?
You have different columns for different.
So those columns, actually, if you fit in a relationship word, you will fail. because it will sometimes become too complex because now you need to add information on top of other things because tomorrow there will be some new features coming up and your database will not be filled for it. Once you build your application, then you think about the analytics. And the analytics part, the beauty is that we have established this link that you have the database and then you have the analytical piece. There is a pipeline. We call it link. The pipeline, it automatically built it. So you just ingest the data and based on of course, the read, you need to know what you are looking for. If you have a column, but you don't know what is the purpose of what you are looking for, the analytics will not help in that. So you have to first bring the data and then you need to do aggregation based on what you need. Now, if your KPI changes and that has another feature, you can start analyzing that afterwards.
And clean the data on the pipelines and then get.
Yes, of course.
No, eventually it'll be relational.
Because
Yeah.
for a relational, why relational? Because the reporting is always work on relational. You have some dimension and KPIs. If you do the relational directly on NoSQL database, it will be a nightmare
Yes.
because the reporting engines are not optimized for that.
Yeah.
I have another question. Can you configure CosmosDB to be ACID compliant?
Sorry, as a client?
So ACID compliant.
Asset it is asset compliant.
Okay, so you can do like
Yeah.
consistency.
You have atomic. What atomic means? Whenever you
Yes.
do a transaction, you want it to be completed. Okay. Your consistency, yes, it is consistent. The integrity, the durability, that is all the asset transactions are in Cosmos. And there is consistency.
Transactions and
Yeah.
stuff.
So there is you remember Julien would have said the different consistency level.
Yes.
So based on the consistency level, you define how you want to set it up. There are 5 different type of consistency. I don't know if there is new we have released, but I'll give you an example. Classic example again coming from my experience. And this was one of the first use cases on Cosmos which we published globally. Domino's. Okay. Domino's initially 5 years back, I think I was on that account, and they said that we have 3 regions. Their headquarters was in Australia, they have Europe, and they have Japan. Okay, and they said we want a database which can serve all 3, but the data needs to be in different locations. And we want sometime that every region can write it into a lower latency from each location. At that time, there was no database which can do multi-writes. Okay, so what we did was Cosmos DBase has this plan that you can have one read-write region and multiple read region. So what we did was we were changing the configuration such that we will make the region where the sun goes as the write region to reduce the latency. And afterwards, after 2 years, we introduced the read and write that you can have multi-reads and writes, but then you have to release the consistency because you need to know what consistency you require if multi-regions are write to multiple locations, how you make the asset transaction. So that's the consistency level based on the use case you have to define. And that is in your control.
Nice.
Yeah.
Database for everything.
Yes, yes.
Yeah, so just I will not go too deep into it, just to give you an overview about what you need to think about when you think about moving from a relational database to Cosmos potentially. What kind of data modeling question you need to think about? Just to give you the way Cosmos DB is organized into Azure and the type of resources that we have. So you have the main resource of Cosmos. It's what we call an account. So Cosmos DB account. This is where you will find, the security, the connection strings, all the configuration of Azure replication, consistency, and so on. Then in your account, you will have several databases, one or several databases, where you will manage potentially the throughput that you want to provision, because you can provision the throughput at the database level or container level. So containers are like tables in a relational database. Database is like a database, a schema. And your throughput can be either provisioned at the database level and shared between the different containers to your database, or it can be provisioned at the container level and dedicated for each container. Or you can mix both. You can have a shared throughput that can be used by some containers, and some other containers can have a dedicated throughput. It's a way to optimize the cost of usage of Cosmos. And in the containers, you will find your items, which are your JSON documents. And so, of course, main difference between relational and NoSQL. You will have tables and relationship, so highly structured data. And you will have JSON documents, very flexible because you don't enforce any schema, where you will have properties with values that you can adapt as and can evolve into the same container. And when you think about the data model, most of the time you will have most of the time, not all the time, database first, and then you think about your application. In Cosmos, because of course you will think about how you will structure your documents, you need to start with the queries. So you need to know what kind of queries you will execute to be able to define the right data model, the right partitioning, the right indexes that you will have in CosmosDB. So denormalization, you will have, of course, better performance, but you need to more complexity in updating your documents because you will have your information in several documents, or you will have one source of information, so you will not duplicate your information, but it means that you will have to read and write on different tables. When you do the data model, you can have different approach. Either you will think about having everything in one document. Why not? Depending on the size of the document, it can be a good option. If you have IoT, for example, with device information, generally you don't have a lot of information in a document. Mainly, measure and numbers is fine. One thing is in Cosmos, the size of your document will have an impact on the cost of execution of your query. Because I told you, when you provision Cosmos, we use what we call the request units. And request units are an abstraction of the resources, physical resources, needed to query your documents. It's an abstraction of CPU, memory, and IOPS. So bigger will be your documents, bigger you will need resources, or more you will need resources to read this document. And so it will impact, of course, the cost to access to your documents. But it's an easy way because you will have all this information into one document, so you don't need to do several queries to access to your data. Referencing, it means that you will have probably one document with a list of IDs, and you will have several smaller documents that you will need to access to. So you will need first to access to the main document, and then to access to the different documents that you want to get with your query. The good thing is generally it's smaller documents, and so it means when you need to update or to get the information, it's easier. And the last thing is hybrid. You mix both. So you can get some information into one document and some information that will be referenced into other type of documents, but you store both into the same collection. And the only difference will be potentially a property that you will use to say, okay, I want to get my main information when I'm doing my query. So I'm doing a select star from my collection where type equal vector, for example. Or I want a specific information. So I will do a select star where type equals song. It's just a way to organize your data, just a way to store your documents into Cosmos.
So it's the same thing like when we come from, again, the relationship world, because you will understand that, right? You are told to normalize everything, 3NF and 4 or 5, whatever we discuss. But when we go into very too much normalization, there was always be performance issues because we have to take a lot of joins. Okay, customer to order, let's say order detail, then you go to price detail, and things like that. So you have a complex join. Okay, the same concept. The Julien is mentioning these are the different techniques, but based on your use case, then you have to decide which technique you want to follow. You have the options. Either you just combine everything in a denormalized, which is usually preferred. But the main thing is if your document become too large, or for example, you are maintaining customer orders will grow with time. So you cannot put everything in one document, right? So based on your query, you decide like how and this is one of the key things where a lot of people like coming from relationship world, they struggle. One, how can I design the model like this structure, and which technique I should follow? And there is like techniques that we can come up with, but yeah.
The relationship model, we overcome this problem by building a data warehouse where you do not denormalize. How about this model? I mean, do we do the same thing, sort of a data warehouse?
No, like the main thing is again, the data warehouse problem is solved because that is a different use case. You keep your original OLTP database as it is, like a true form.
Yes.
You transform it. Yeah.
Database, exactly.
So the same thing, you just keep it true for your application. And once the application is done, then you take this as a feed to your
It's gonna be at the feed of the.
yes, yes. It is not going to be a data warehouse. It is going to feed to the data warehouse.
The NoSQL API in the past was called SQL API because of the language which is used by Cosmos to access to the data. Because you can see it's very similar to SQL, where you will find, the same keyword select from where. So a lot of similarities, of course, more limitation, less evolved, but similar in terms of syntax. Why is it important to use? So we spoke about the fact that CosmosDB is a distributed system using several servers, small servers to store your data. And why it's important to think about the partitioning of the data. So the way you will logically group the document together on these physical servers and use this information in your queries. Because when you use your partition key into your query, it means that you tell to the system exactly where it needs to go to get your information. So it's efficient, it's performant, it's cost effective. When you don't specify, so if you are using another property which is not a partition key to access to your data, of course it can do it because we have indexes. But it means that to access to the data that you are looking for, you need to access to more physical resources. And so performances will be lower. And the cost will be higher because you access to more physical servers to get your information. It's like you are doing a full scan in a database. Okay, I will just skip different slides. So schemaless data model, meaning again, you can insert any type of document into the same container. There is no schema enforcement, so you can index everything. What else? Yeah, and in Cosmos, so you can also specify what we call the indexes policies, because we have different type of indexes that you can use in Cosmos. You even have a geospatial index if you want. We have the vector indexes. One of the best practice, and it's a database, so it's like in SQL. If you have too much indexes, of course, it will impact the write on your database. It impacts the performances to insert data into your database. That's why, in terms of best practices, by default, CosmosDB will index everything. We want to make it easy for everyone to use Cosmos, so we just index everything. You access to your database, you query with any kind of property, and it works. But of course, we recommend to customize the indexes to enhance the performances. We recommend to include or exclude only the properties that you are using. So either you are excluding everything and you include only a few properties because you know that you will use only a few properties in your documents. So you specify the path of the information that you want to index. So this one will exclude. So you specify the name of the properties that you want to exclude into your document. And this one means that you are including everything by default.
So again, on this one, in relational world, you do index explicitly. In here, you exclude explicitly. Okay. And the other thing is, again, on the NoSQL database, I remember when I was trying to do this, it's not just about like the variety, okay, like the structure or the things. There are like the classic V, okay. You have volumes. If your volumes are very large on analytical platform, okay, normally in the relationship world, it will be just a single machine. You have to go up, 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 up. Okay, this is distributed. So the volume, if it's this, you can distribute it. That's why the partition mechanism is important, because it's grow horizontally. Okay, because the higher machines are very expensive. The extendable are a bit cheaper, but you can have more. Okay. The other thing is, so we covered the volume, the variety, you already covered that, and velocity. Like these are the different things that you don't have to just always think that, okay, I can just put, when the structure is JSON, I have to put it. You can put even the structured format in a JSON structure, and then if the volume is more or the scenario is such, then you can put it in here. Like I'll put it in just for 3 columns. The consider recommendation engines. Okay, what do you need? You need the customer ID, you need the item that you recommend, and the ranking score. Okay, you can put it all in here. Okay, or for example, I have done it like in my case, there was so much large volume of the price and the quantity. Consider that you have like 1,000 stores, 1,000 item in here, and you have to maintain the price and the stock every second. So you have that volume that you cannot update it in the relationship world. Or even if you do it in a relationship world, it will cost you a lot. So the non-relational world make it much, much easier.
In your custom indexing, you rely on your own analysis of the data, or there is some like tools like SQL Profiler where it will suggest some indexing, or you need to do your own analysis?
But we have 2 things. We have what we call, so we have different metrics which are available in Cosmos. So you can enable the query metrics to get information about the usage of your indexes in Cosmos. And we have also the advisor in Cosmos that can suggest indexes to create to optimize the performances of your database. I want quickly to speak about MongoDB specifically and CosmosDB for MongoDB vCore. So we have seen that we have CosmosDB for NoSQL. We have CosmosDB for MongoDB request Unix base. And we have a new offer, which is a vCore base. Why? Because, as I told you, in fact, we have CosmosDB, which is a database engine. On top of it, we have a layer with where we are exposing different APIs. So except for the core API, which is the main one. And of course, this layer, it's a compatibility layer. And so it's not fully compatible with all the version for Mongo, at least, because MongoDB is a solution which is evolving, very fast. They are releasing new version with new features very quickly. And because it's not open source, we don't have access to the code. And so it means that we need to do reverse engineering to be able to implement new features. And so we had some limitation with request units and some compatibility. Or the level of compatibility was not good enough for some customers who wanted to be always, on the last version. So we worked on a new version, new offer, which is called MongoDB vCore, which is a managed kind of managed instance of MongoDB, which is almost fully compatible with MongoDB, the real one, let's say, but with some value proposition. We provide a solution which is cheaper than MongoDB Atlas. So all the SKUs that we are providing are cheaper than MongoDB Atlas. We can scale, so we have big nodes. So we have nodes with up to 32 terabytes of data per node, meaning that you need to have less nodes or less servers than MongoDB Atlas today. If your workload is to store a lot of data, but where you don't need to have a lot of compute. And of course, integrated, so the support is provided by Microsoft because it's an Azure service. We did some performance tests internally, of course, and we provide better performances than MongoDB Atlas with better capability to scale also and faster. And we have integrated into also this offer, so the vector search from Microsoft, this KNN, integrated with Azure, and we have different SLAs which are covering the platform. So this is some comparison in terms of pricing. So it's public prices, of course, where you can see, in fact, the difference in terms of pricing. So even we have capability to have MongoDB Core with high availability and without high availability. And you can see that even with high availability, we stay lower in terms of pricing than Atlas. And this one is a comparison to show you, the impact of having big nodes, so large volume of data per node in terms of pricing. If you compare, with nodes of 4 terabytes, we have 42 terabytes, and we have 64 terabytes which are coming. And you can see what would be the impact with or without high availability on the pricing. And this is the architecture of MongoDB Core, so the service. It's very similar to what you can find with our managed database like PostgreSQL or MySQL or even SQL. So you will have a virtual machine with, so MongoDB has the concept of replica set. So you will have 3 copies of your data and 3 servers per instance of MongoDB Core. And you have the ability to have a standby instance in another availability zone if you enable high availability. So it's different configurations that you can find. So either you have one server with no shard, no high availability, one server with high availability, so you will have a standby server, a replica of your server standby, and you can implement shards. So shard is to scale horizontally your data, and you can have multiple shards also with high availability. And in terms of flexibility, so it shows you that the fact that you can scale independently the compute and the storage. And so if you can start small and you can increase the size of your shards, of your servers, when you need to scale. And if you need more compute, the same thing. You can change the SKU of your machine and go to higher SKU without any downtime. Because it will instantiate, the new machine, and when it's ready, it will automatically switch to the new machine.
And do we still offer the free tier to? Yeah, so just to let you know, there is already a free tier of CosmosDB available to anyone. So if you want to try, you don't even have to have like some money or credit card. You can spin it up and you can start working on it and see it.
These are only 1,000 requests, right?
Yes, but 1,000 requests, consider 1,000 requests per second. It's like 1,000 requests per second. So when we say RUs, that is request unit per second.
Yeah.
Okay. So 1,000, like if you want to understand it, I don't know if it's like if you're doing a singleton operations. Okay. Just by default, you can consider 5 RUs per second for each instance for 1 KB token. So if you have 1,000 divided by 5, you can have 20,000 inserts per second. In read, if you are just using 1,000 and you are using on the ID, you can have 1,000 reads per second. So still like a lot. If you are not learning, you can still do a lot with this RUs.
I've got just a few slides about new features coming. First thing, it's again in objective is to make life easier for developers and DBAs. So we have integrated into the Data Explorer, so the interface of CosmosDB to access to your data, Copilot. So it means that now you can use natural language to ask information to Copilot, and it will automatically translate your query into a CosmosDB query, optimized, of course. So it means that you don't need to think about the documentation and read about all the information about subqueries, about join or anything that you want to do or achieve with Cosmos. Copilot will do it for you. Integration of MongoDB vCore in Azure OpenAI Studio to use vCore as a source for building your own copilot with OpenAI Studio. The different options that we will have. So I told you we have different type of indexes available, and depending on your need and the type of use case that you want to implement, one or the other will be more adapted to what you want to do. So the last one is, again, the one which is developed by Microsoft, which is, of course, providing the better latency and the better cost of, the best cost of usage. It's just a detail about how this can works. So basically, storing information into RAMs and SSD drives. You have one index per physical partition in Cosmos. And this is a way that you can enable the feature in Cosmos. You just need to go to the features and you enable the vector search for NoSQL API, and then you can just create vector indexes on your container and start to use the feature.
Do you have any questions, by the way? Like, because I told Julien to have content for 2 hours. So that's why I have gone quite deep into the details as well. But yeah, if you have questions and things like that, we will be happy to address that. Yeah.
How the indexing is happening per field level? It goes at the nested, means if the field JSON is nested, it will go at the field by field level. But what type of matrices it is capturing? Like minimum, maximum value count, or?
So I have to check the internal one. Maybe Julien can say, but it's like consider that any index, right? Like the database world, how it's done. Okay. Either you just like retain the range of value because there's different type of queries. Okay, and similarly, there's different types of indexes as well. If you are doing equi-joins, like equi or like equi-conditions, then you just say this value equal needs to be this. Okay, then you need one type of indexes. But when you do a range of this, then it need a different type of ranges because you need to select a value. Okay, so a lot of times when you create like the main ID or the main partition key, that needs to be in a particular way because you need to reach that distributed mechanism. Okay, but under the hood, I don't know, like I can give you maybe research paper and you can see it, but that is the complexity which is removed from the knowledge. If you are creating a NoSQL database, probably you need to know it. But under the hood, if it works, I don't bother. I just like use it, give me the SLAs, which is guaranteed, and you just like work on it. Julien, if you want to add anything. So.
Yeah, no, we need to check also the documentation because I didn't check indexes since a long time.
Yeah.
I just wanted to finish with the pricing because it's also important. We have two types of offers so in Cosmos. We have the RU based, so what you will find with the CosmosDB for NoSQL, and we have the flat fee because it's based on a type of machine, so SKUs, for MongoDB vCore, for PostgreSQL, or for Cassandra Managed Instance. The way it works for RU based, we have this kind of, let's say, ABAX, saying that we have request units, so abstraction of physical resources. When you read a point read, so it's when you get one document by the ID of the document, 1 kilobyte document, it costs 1 request unit. When you do the same thing with a document of 100 kilobytes, it will cost 10 request units. It's not something which is linear. It's there is some ranges, and depending on when you are. So, for example, from 1 to 20 kilobytes, it will cost 1 ARU, but from 20 kilobytes to 45 or something, it will cost 5 ARU, and so on. When you write a document, so it's more expensive to write a document than read a document because when you write, you persist the data in several servers because you have copies of your data. So you access to more physical resources and you update also indexes. So it will cost for 1 kilobyte document, it will cost 5 request units and 50 request units for a 100 kilobyte document. And of course, depending on the complexity of the queries that you will execute, depending on the fact that it's using indexes or not, is it using the partition key or not, are are you doing any manipulation into the query or not, the cost of execution of a query will depend and will vary. So here in this infography, you have description of the different modes. So the different model, manual provisioning, auto-scale, serverless. What we are using for pricing. So you pay per request unit per second, which are provision. It's early based for auto-scale too. So it means that for auto-scale, you pay for the maximum that you have consumed on 1 hour. And for all of them, you have, in addition, the storage. So you have two components. You have, let's call it the compute and the storage. Storage is something which is fixed, depending on the region. You pay per gigabyte per month. And you will add, of course, if you use your replication, so you will multiply by the number of regions. Same thing for the storage. If you add also backups, so by default, we have 3 backups, but you can add additional backups, you will pay for it. And then you have different ways. So either you have a pay-as-you-go, the default one, or you can buy reserve capacities. So you buy in advance, you reserve some capacity in advance that you can pay monthly on 1 or 3 years. And so to help you also to define the right sizing. So first option, you know exactly, the pattern. So you know the number of queries, the type of queries, the size of your documents, and so on. We have so what we call the capacity calculator, where you can enter all these parameters, and it will give you an estimation of the number of request units per second that you need to provision. Otherwise, you don't know all this information, and you are moving from maybe an existing environment other than Cosmos. And so you can convert the number of vCores that you are using today, so in your virtual machine, to request units to have an estimation. And then you can use the pricing calculator, Azure pricing calculator, with your information to get an estimation of the pricing. This one is just to give you, so what we have seen at the beginning, manual throughput, the fact that you provision a specific amount of request unit manually, and so you pay always for this amount, even if you are not consuming all the resources that you have provisioned. You have auto-scale. Auto-scale, we had an evolution. We had an evolution just before summer. So we had what we call auto-scale B1. And basically, you had a maximum. You were paying between 10% of the maximum and the maximum. But the system was based on the maximum consumed by a partition in your system. So you see in this configuration, we have 2 regions. Each region has 2 partitions because it's a replication. But when you have 2 regions, it can be, you can have different workload on each region. So you can have different consumption of resources on each region. And so in this case, we have 1 partition which is consumed more in 1 region. And in auto-scale, even if, of course, you will not pay always for the maximum, you will pay for the maximum consumed by the hottest partition, physical partition, in the system. And so it means that even if the other were not consuming so much, you will always pay for this one. So it's lower than the manual, but it's still more than what you should pay. And so this is why we have released dynamic auto-scale, where now the bill is adapting to exactly to the consummation of each of your physical partition. So it means that with manual auto-scale, you will pay for 4,000 request units because you have 2 regions. So 2,000 multiplied by 2. Why 2,000? 1,000 per partition, yeah. In auto-scale V1, you will have paid for 3,200 because it's based on the maximum, so the hottest partition. And with autoscale V2 or dynamic autoscale, you pay for the consumption of each partition. So in this case, 1,900.
I'll ask a question. Why the two, what, like, you have heard the things, but why there is a difference? There is two partitions, but why one is higher than the other one? In a distributed system, why would that happen?
A US-based company, and region 1 is in the US, and region 2 is.
Yeah, or for example, you can also think that you have designed the partition in such a way, like a classic example. You have data coming on per day basis, and you decide the data as a partition. Okay, in relationship word, that has a different meaning than in here. The partition, if you just put like all the data in a single day, let's say today is like the Sunday, and Sunday is the one which has a lot of data than the other days. It will become hot partition. Okay, so it's about the partition design. Consider that you are doing on the let's say the category type, like in the cross example. So let's consider that oranges are sold a lot in Carrefour. And if they have selected oranges as the partition ID, the oranges will always be hot because that will be sell more and that will be queried more. So you need to decide what partition is mechanism. And that's what Julien saying is that if you have one hot partition, that is the one which is taken care of. So distributed systems, I told you, it's a distributed system. There will be always node and you need to decide how to partition the data equally. The more equally it is, the better performance and the predictability you will have.
Why did you ever use autoscale V1?
No, in fact, it's not a choice. It was the implementation before we release autoscale V2.
Makes sense. I was thinking like, why would you voluntarily?
Yeah, exactly.
I think we are right on time, Julien. If there is some last things you can highlight, otherwise, yeah.
Yeah, it's just so you need to register for autoscale V2 because it's not rolled out yet to everyone. And yeah, no, that's it, I think. So yeah, or to get, you are asking for CosmosDB free tier. So you still have, of course, the free tier, 1,000 request units per second. Or you can have 30 days free and so on. Yeah. And you can use the emulator. Emulator is also something that you can install on your laptop or on a server, which is emulating, of course, the different features of CosmosDB. Yeah, that's it. Just on time.
I told you, we will manage the time. Questions? Or you guys are hungry? Team, for next thing, we haven't decided the topics, but I would expect if you guys finalized. Okay, that's good. If we finalize, then we will, the next one will be then from the community. Afterwards, if you don't have any nomination, then we will start maybe IoT series. Well, I'll check how we can do that, maybe two or